Okay, so we're matching the slope fields, and we're going to look at question number 2. We already found that on question number 1, this slope field matched with B. So on 2, we have dy dx, or our slope, is equal to x minus y. Now in this case, we don't have an autonomous slope field because our derivative depends upon both x and y. We might want to find critical values or critical points by setting our slope equal to 0. If we set our slope equal to 0, we're going to get 0 is equal to x minus y. If I bring my y over to the other side of the equation, it tells me that y is equal to x. Wherever y is equal to x, my slope is going to be 0. So if I do my slope field over here with my xy axis, let me change my color. I know that where y is equal to x is this line that separates the first quadrant and the third quadrant in half, and so along this line I'm going to have a slope of 0. So I'll do some little horizontal line segments. That's where my slope is 0. And then what I want to know is, to the right of these horizontal line segments, does my graph increase? Is my slope going to be positive, or does my graph decrease? Well, it'd be negative. And the same thing to the left. Is the graph increasing or is it decreasing to the left? And so we want to find out where it's increasing. The graph is increasing when the derivative is positive, greater than 0. So if I have my derivative greater than 0, that would tell me that x minus y is greater than 0. If I bring my y over to the right side, it tells me that when x is greater than y, my slope is increasing. Okay, well, where is x greater than y? X is greater than y to the right side of our horizontal line segments. It tells me that to the right side, my graph is going to go up. To determine just how fast it goes up, we could choose some points and check them. In fact, let's do that. Here, if I go back to our guidelines, the first question says, what happens when x is 0 and when y is 0 along the axes? So this one, because my slope depends upon both x and y, I can determine those slopes. When x equals 0, my derivative is just negative y. So my slope is negative y, which means that if I make this 1, 2, and 3, when y is 1, my slope is going to be negative 1. When y is 2, my slope is going to be negative 2, a little bit steeper. When y is 3, my slope is going to be negative 3, steeper still. So this will be negative 1, negative 2, and negative 3. When y is negative 1, my slope is positive 1. This at negative 2, my slope is going to be positive 2, and then positive 3 slope. And as you get further away from the origin, your slope gets steeper. Okay, now how about when y is 0? That'll tell us what's happening along the x-axis. When y is 0, that y term is going to drop out. The derivative is x. Y is 0 along the x-axis. And so let me find some points here. So this will be 1, 2, and 3, negative 1, negative 2, and negative 3. At 1, when x is 1, the slope is 1. It's a positive slope. When x is 2, slope is negative 2. It's a little bit steeper. And then 3, slope is 3. And that should even be steeper still. And when x is negative 1, you're going to get negative 1 as the slope. Here at negative 2, you get negative 2 as the slope. At negative 3, you get negative 3 is the slope. It should be steeper as you go away. Okay, so let's go back. This isn't true. This one's not true. 2 and 3 are not true. 4, what happens when x goes to infinity or when y goes to infinity? So what's happening on the right side of the graph and what's happening on the upper side of the graph? As x goes to infinity, well, if y is going to infinity also, then this is going to 0. So when x goes to infinity, that's to the right side, and y goes to infinity, that's the upper side. Our slope is 0. That's shown by this horizontal line segment in the upper right hand corner. This is horizontal. And the same thing on the left side. When x goes to negative infinity, then x is very negative. If y goes to infinity, the upper, then you're going to have negative minus a negative. This is going to be a very negative slope up here. So this is going to be coming almost vertically down, but not quite. In the lower left, we know this is a horizontal line segment. In the lower right, that's where x goes to infinity. So this is going to be a positive x. Y is going to be a negative, so we're going to be subtracting a negative. So these are both going to be positive. And at this very bottom right part of the graph, this will be going up almost vertically again, but it will still be going up to the right. So let's see if we can draw some of these. It's going up here, up here. It should be coming across here. Up, up. On these parts, it's increasing. Here to the left, our slope is negative. Very negative coming from here, coming from the upper left. Levels out, and then comes over. Well, that's kind of messy, but let's look at some of our flows. If I do this, let me choose a felt tip pen and a light color. And if I choose an initial point up here in the third quadrant, my slope is going to be negative. It's going to level out close to the origin from where I started. And from the origin, it's going to start going up in this region. If I start down here in the third quadrant, my graph starts out relatively horizontal, and it's increasing here, and continues going up. Okay, so the defining points of this graph are those horizontal line segments along the line x equals y. And we can easily determine that to be graph D. Here we have our horizontal line segments along x equals y. Notice that when x is greater than y, the graph is increasing. So it's increasing here. And when x is less than y, the graph is going to be decreasing. And so it's decreasing here. Which is more or less what we have. So D. So when you're drawing these slope fields, what I'm really looking for are, do you have those critical values where the slope is equal to 0? Are those marked clearly? You should use short line segments to define those points. Do you have the area where the graph is decreasing? The actual amount that it's decreasing, whether it's decreasing with a slope of -4 or a slope of -2, I won't be real critical on. But I do want it to show that the graph is decreasing on those areas. And when it's increasing, do you have the little line segments to show that the graph is going up to the right? These all should be done with little line segments. Don't use a solid line to show it. And then also on a test, I may give you an initial value. You should know how to plot that initial value on the slope field, and then how to use that initial value to guesstimate what will happen over time. What is the equation of the line with that initial value?